Hi folks, this is Adam, back with another Cancha geometallurgical software tutorial. Today I'm going to talk about the resource table feature that we've got in the new Cancha 2.2, which has just come out in July 2021. For this I'm going to be using this Bonnie example dataset, which you can download from our website. And without further ado, going to get into the resource table, which is a tool to help you understand how the sample population relates to the block model and the domains within the block model. You're going to find that within the analysis area at the top, and you'll notice that there's a new button here on the right, which is the resource table. Clicking on that opens up this form. Now for the resource table, remember on the feature list here on the left, you always have the drilling, the block model, and the metallurgy. And in this case, we were interested in the block model because it's the resource. Okay. So we're going to go ahead and pull in the elements of interest, which would be, for example, gold and silver, because it's a gold project, precious metals, and we've got the outer grouping, inner grouping, and the density. For now, let's just go with the outer grouping, which would be our oxide, which is oxide categorical feature, which is kind of like the default sort of geometallurgical domains, the best explainer of how the metallurgical response is for recovery in Bonnie. So we're going to put that for the outer grouping, and we need to put it in density. So the density should always be coded into the block model. Of course, the volume of the block model is known by Cancha because it's the size of each cell multiplied by the number of cells. But the mass is determined by the density. You have to talk to the people in charge of the block model to know how they've coded it. Sometimes it's got a thing like dense or density even. In this case, it's called ISBD, which I guess is short for in situ bulk density. So I'm going to pull that into the density field here, and you can see that it pops this table up for us. In this table, we've got the total at the bottom, but then we've got it broken down by these oxide domains, oxides and transitional and fresh. And for each one, we've got a mass. So this is obviously the megatons, because we're presuming everybody's working in metric. If you're not working in metric, best of luck to you. But if you're working in metric, then what it's doing is taking the distance in meters for each of the blocks, the volume in meters, multiplied by the density in tons per cubic meter, and then it just estimates the mass. This isn't good enough for resource estimates. There's a lot of things like, for example, subcell models that might, little idiosyncrasies that might be mean that this is a little bit misleading. But as far as geometallurgical sampling and good enough for geometallurgical sample distribution reviews, I think this is quite good. So we've got the mass estimated for each one of these domains, and then the percentage of mass of the total. Take note that there's no filters implicitly in this. If you want to filter out blocks that are barren or waste or outside the pit, then you'll have to do the filters, or even trim the data before you import it into Cancha using the import trim. But basically, you need to filter that data out. This is going to do this calculation based on whatever, in this case is, 19,618 blocks in the block model, and it's using that for this filter, for this table. So mass distribution, gold grade average. So this is the weighted average. So it's taking density into account when it does the averages. Okay, so it's the sum of the mass of each block multiplied by the sum of the grade multiplied by the mass divided by the total mass in each domain, and then also for the total. So that's basically the grades. And if you wanted to add another grade, say we wanted to add arsenic, for example, we could just pull that in. It's going to update the table. And so now we've got the metallurgical samples on the right here. Phase 1, Phase 2, Phase 3. So basically this way it's broken down is by phase. And it gives you the number of samples in each phase. So 7 samples in phase 1 in oxide 1, 2 in oxide 2, and 1 in transitional. And so then I'll give you the total number of samples in phase 1, and the total samples in each domain, and the total. And then percentages of samples. Now this is where it starts to get interesting for geometallurgical sample representativity. You can see here that 62% of the mass is in oxide 1, and 75% of the samples were from there. So maybe it's overrepresented. Whereas, for example, transitional material had 15% of the mass in the block model, and only 4% of the samples, only 2 samples in the transition. So maybe it's underrepresented. So that might give us a clue as to where we might want to take more samples from for phase 4. Okay, so that's basically how the table works. There's one more thing you can do. You can also pull in another categorical thing and do that as like for the inner group. So we could do that, for example, by code. You could pull in the code, and that's categorical. So we can see C1 and C2. It starts to give you detail within each of the domains, within each of the other domains. So for each code within each ox, it gives you the same thing. But of course, also being Cancha, you can also use numericals as categoricals, and it'll just break it down by ranges, and those ranges are established in the legend, of course. You know, if you want to see that, you just go to right click on the feature legend, and these are the categories here. So basically we can do that for both the inner and the outer, if you want to do that like that. So you've got low, medium and high grade gold within each of the very low, medium and high and very high grade copper domains. Of course, you know, you can look at a block model in many different dimensions. So I recommend that you know, have a good think about what dimensions are useful for you. Okay, so that's basically it. That's the new feature for resource table in Cancha, and hope you get good use out of it, and hope that it's useful for you in order to find out how representative your samples were with respect to the resource. Great. Thanks for listening, and feel free to get in contact with us any questions or suggestions. Thanks. Bye.